Hello, everyone. Welcome to our second keynote talk of the day and our third in FDG so far. I hope you're enjoying the conference. It's been a fantastic day, and we have another fantastic speaker here. We are extremely fortunate to have Sahar Asadi as our second keynote. Sahar is an AI research lead in the R&D department at King Digital Entertainment. And that makes her one of the most influential research minds at one of the biggest companies in the games industry. In her work at King, she has spearheaded research into how AI can support content creation in some of the biggest, most complex, and most demanding game development environments, and still found time to write papers and collaborate with academics on cutting-edge machine learning research. She also co-organizes Women in Data Science, AI and ML Sweden, helping support the growth of a strong community of women in these fields. I'm extremely grateful to Sahar for coming here today to share her knowledge and expertise with us. And without further ado, I will hand over to her now. Thank you, Sahar.
Thank you very much. Happy to be here. So let me share my screen. Okay, and let's do this also full screen. Okay, cool. Thanks for having me. In this talk, as Mike mentioned, I will talk about content production automation. I mean, you all are familiar with games and AI, and that's why we are here. They go hand in hand in a very long history. But in particular, in the past 5-6 years, there has been a massive growth in research in this field, in particular also in the area of game playing. So there have been benchmarking on Atari games, trying out state-of-the-art algorithms, on OpenAI trying Dota, and also, like we have all heard about AlphaGo Zero. There's been a lot of massive resources that has been thrown to these problems. But what is missing very often in the research is the challenges that comes in when you want to try them in industrial application. And that's the area that I want to talk about in this presentation. So talking about AI for game development and playtesting, I wanted to emphasize here that when it comes to trying gameplay, we are not interested in industry in surpassing the best human performance, but rather we are focusing on human-like gameplay and assessing the quality of the game that we are putting in front of our users. So, the other area that I want to also talk about is also what we do at King when it comes to content production automation. So for those of you who are not familiar with King, we are focused on cross-platform casual games, and we've built a lot of mobile games. We have 4 global franchises. You might be familiar with Candy Crush being the biggest of them. And also we have a lot of new games that we are producing. When it comes to the volume of users and content, we have a large user base. But we also have a huge volume of content with a wide variety that is continuously growing. If you think about only Candy Crush Saga game, there are more than 7,000 games currently released, and this volume is continuously growing. So with that, we get to a point to maintain the quality of content at this scale and providing a good user experience. We needed to start focusing on content production automation. And that has been one of the areas that my team has been focused on recently even more. So talking about content, let me also show you a bit about how our content look like. So this is Candy Crush Saga. It's a puzzle tree. It's a match 3 puzzle game. As you can see here, there are various types of candies with different colors. There are some blockers we have different type of blockers. There's a move limit in each level, and there's also an objective that you want to fulfill. In this case, there are 57 jellies that you want to break and release candies within the move limits that is given. So what happens is that if there 3 or more candies of the same colors that are matched vertically or horizontally, they disappear from the board, and the candies will fall from the top to replace them. And these candies that you see, these are special candies that they have wider effect than just like, you know, clearing the affected cells, which you can see, for instance, here. Yeah. So talking about content, our goal is to provide a good user experience, which is, and we want to build game levels that are fun to play. We also keep that in mind, that we want each level to fit the journey of user in the Saga. So we don't want to have continuously easy levels, but or like, you know, having continuously difficult levels. So designers keep that in mind when they are creating sequence of our levels. So looking at the looking at the content lifecycle, they are so after a content is created, there is an iteration of just making sure that it's a good content, and then like if we are happy with, we are releasing it. When it comes to live content, there is also like, there's a content management work, and if we identify levels that they are not providing good user experience, we want to tweak them a bit to resolve the issue, and we iterate over, and if we are happy, we release the content. But these iterations, they are really time consuming. And that brings us to, can we use AI to support designers to focus on more creative work in content creation? And this is area that we started to focusing on. So we put together the gameplay testing and content generation in one context, and started working on this area. And of course, also talking about production, we spent a lot of time in infrastructure. And these 3 pieces are the pieces that I'm going to talk about in this presentation. Talking about our journey, it has been a long journey with a slow research. At the beginning, we started more focusing on building a bot that can play the games, and then we moved towards trying out more advanced approaches. We currently have a bot that is in production, and we also started looking at content generation more recently. Talking about the bots that we have currently in production, I mentioned that we are looking at human-like playtesting. Let me tell you how that works in our game. We are applying deep learning. It's a supervised approach that we are trying. What we have been doing in order to train our agent is that we take the state of the game before a move, and then we look at the options of the move, and we look at from the label data that we have from our players. We give that label to our model to say what action human players made in order to train this bot. We trained this bot, and we saw that if you look at player success rates in this level, for instance, like we looked at in a large number of levels, and we looked at its correlation with our agent success rate, and we see that like we see a human-like playtesting. But it's also worth noting that like the level, if it becomes like a super difficult level, we see some divergence in the performance. So the thing is that we don't have always data, especially if you think about the cycle of playtesting and generation. We don't always have this player data. Also, when it comes to new games, we don't have player data. And this is where we started looking at reinforcement learning. I think you're familiar with reinforcement learning, but just very briefly, you have an agent that is interacting with an environment, moving from one state to another state based on by performing an action given a policy. And if the agent is performing a task by moving around in these states with taking actions, if the agent is succeeding in the task, we give a positive reward to the agent and back propagate that reward through all the the actions the agent has taken in these states. So what we are trying to do is actually we want to we want to have a policy that maximizes the expected accumulated reward, or our Q function, with the agent. There are several approaches that has been introduced, and here I want to talk about the challenges when it comes to applying reinforcement learning in actually industrial applications. So the first, talking about application, that's actually the first challenge. What we realize, and also we have seen like in some of the previous works, that is when you want to choose an approach of reinforcement learning from state of the art, you also need to look at the context of your application, if it fits well with the nature of your application. In this particular case, we have been looking at a puzzle match tree, which is different from a typical Atari game, for example. One of the most important or difficult challenges is regarding reward selection. The rewards that I mentioned is sparse, meaning that, like, you know, in this particular case, when you win one level of candy, there's a large sequence of actions that has been taken, and this leads to a sparse reward. So we started looking at if we can find a reward that's first is like reflecting the level objective, and it also helps us to have a faster learning. Another aspect that is important is generalizations. As you see, like in match 3 games that we have several game features, we have different types of boards, we have a lot of different objectives, and it's what we are looking for is that whether we can have a better generalization from the agents that we are building. And finally, it's scalability. And usually reinforcement learning is computationally expensive, and we are looking for approaches that have a faster convergence. We have been testing on Candy Crush Friend Saga, one of our games in the Candy Crush franchise. In this one that we are focusing here, it's about spreading jam over the board. And if you look at here, if a candy is covered by jam, when you do a match, then all of the candies involved, all of the tiles involved in the match, they will also get the same, they will also get the jam spreaded over them. If a special candy is involved, then a wider range of tiles will be affected. So we looked at both off-policy and on-policy method. We haven't done a very exhaustive research in that area, but we started looking at DQN or Deep Q network as an approach. So one of the challenges that I mentioned is related to the rewards. So we started exploring and see if we can define a better reward, and we solved that. We addressed that by introducing an extrinsic reward, which is based on the progress in the spread of the jam. And we saw that we get a better performance compared to a typical sparse reward. But this hasn't actually solved the generalization problem. So we started thinking about, can our agents learn some basic skills that we can combine them in order to have a better generalization? And with that, we started looking at intrinsic events. So you give reward to the agent when one of the events happens, and you basically give, if an event is more frequent, you give a less reward to that event because they are less interesting. So with that, we created our intrinsic reward, and we ran an experiment. And in this experiment, we are looking at whether our agent learns to create less match 3 candies because they are less interesting and they have less impact, and learns to create more special candies. We are also monitoring if implicitly by only just learning these intrinsic skills or basic skills, it can also pick up the game performance by spreading jam and also like having a better win rate. So here, this is the match tree, and these are the special candies that we trained agents for. And if we look at here at the results, just focus on the blue lines, which is the performance of our agent. And what we see is that as the agent is training, the actually creation probability of match tree decreases, and for special candies, especially these ones is increasing. We also looked at the actual game objectives, and we see this is the progressive jam extrinsic reward that I mentioned, and the blue line is the intrinsic reward. And we see, although like we have just trained it based for the basic skills, but actually manages to pick up fast to achieve the game objectives. So now we get to the more interesting part, which is combining these skills. So we pre-trained each of the skills, and we applied an average bagging on the skills, and we looked at the win rates. So here what you see, we looked at a few levels, and here is this column is showing you testing and training on the same level, and this column that is more related to generalization is training on a few levels and testing on an unseen level. And we see in easier levels where, like, you know, the performance is higher, the agent performs relatively well, much better than the extrinsic rewards and a random agent, and also close to much closer, getting one step closer to the human performance, which makes us happy, feeling like this is a good direction to explore further. I also talked about sample efficiency, and we have looked at a few components of actually DQN, double DQN, and we looked at how we sample from our buffer and actually how we fill in our buffer. And what we see is, what we've learned is that actually the method that you have for selection of samples from the buffer has impact on the training performance. And also we tried to, we looked at whether we can speed up the training by using some demonstration data. What we are doing is that we fill in our buffer or our memory with actions taken by the supervised bots, and this basically speeds up quite a lot our training, because the supervised bot doesn't require interaction with the game, which is quite slow, and boosts the training at the beginning. But we also looked at how in terms of like the number of required steps in the training, how it performs. And we saw that this agent that is trained by demonstration seems to, at least in our early results, seems to showing a better, reaching faster to the same performance as our basic agent. Okay, so this was we are doing a lot of exploratory work in this area, but I want to also tell you the production side of the story. So, I mean, you are familiar, you have heard a lot of talk in this conference about content generation. We started looking at PCG space. We started trying out neuroevolution, looking at trying out GANs. But then we got to these questions of like, how do we actually incorporate design choices in our score function? And what is actually a good level? Then we said that, okay, let's start looking at, having a co-creative space and like mixed initiatives. But then we went back to our designers to have a conversation and try to build up this setup. But then in that conversation, we realized actually like the main pain point is around this piece that is like about tweaking. And we decided that this is actually, if we want to solve a problem that of designers, we actually need to focus in this area. And that's what my team has been trying to work on. And I want to highlight, like when we talk about tweaking, well, in tweaking, you don't generate completely new content, but you are trying to have like minimal changes to an existing content that is not intrusive also to your player. So with that, we started building an MVP. It's not still in production, but it's just like a concept that we are iterating now on. So we have a discovery component where we have like all of our data related to our levels there. And there is like we provide a lot of analysis to our designers. But under the hood, we also have like automatically detect problematic levels based on like guidelines that we have received from designers, or if they are poor performing levels. Then either a designer or like this automatic system can schedule a tweaking, and then we provide some tweaking suggestions. And we collect feedback from our designers, and also then like if it's needed, this can be sent to an A/B test before like releasing it to all of our users. And the data that we are feeding to this discovery comes from player data, from the board configuration information, and also from the bot play data. And when we are tweaking, we basically are looking at the data from the board initialization and like the bot play. We have several engines of like different types of tweaks, and we are exploring in this space to find out which of the levels based on the similarity and the performance is meeting the criteria of this particular problematic level. Here you see an example. So this is one level, and we have with a lot of different tweaks that we have done, but they are very, like as you can see, it's not quite obvious, but it's just like removing some layers from some of the tiles in the board that they have blockers, and it's also like some changes in the move limits and minor tweaks, which has had a much better performance. Okay, so talking about all of those, we spent a lot of time to also build infrastructures, because it's important that, like, you know, we put all of the games and bots in one place. We can scale both research and production. We care about the reproducibility, and it's important to standardize all the training and inferences pipelines and have a way to automatically analyze and assess the results, and also to be able to plug in new services, so such as like what we did for the tweaking. And we tried a lot of different technologies, and we've built our own pipelines where we can plug in different components. And I'm not going to go through the details of the infrastructure. What I wanted to show with this slide, for the sake of time, is that actually building infrastructure takes time, and it's complex, and is important, and worth the effort. Okay, just to wrap up, I want to give you also some learnings from the journey that we went through. One of the very first thing that you should look at when you want to start investing in such projects is the AI readiness in games. So how is the adoption by the game teams? Is the AI part of, we need to put the AI as part of the game strategy roadmap, and a close collaboration between devs and research is quite important, and having ML operation capabilities moved to game teams is also important moving forward. Also, it's important to know the tech that we are working with. So, I mean, especially for reinforcement learning, it's important to know how slow the agent is, and like, you know, if the game is actually ready to apply reinforcement learning. And so going back again, I think to maintain a high quality for user experience, it's the automation and having the scale is important. Talking about AI in game development is important to contextualize that. So content is not an isolated piece in the game, it's the primary piece making up a user journey. And also, we perceive this as an assistive tool to help our designers. And as I mentioned, productionizing an AI solution actually takes much more time than we were initially thinking. And thank you very much. And I wanted to just give credits to the people that they've been involved in my team. So here you can see their nice works in the past few years.
Thank you, Sahar. Mike unfortunately dropped out of connection. He's sending me panicked email, but I'm going to be sharing the couple of questions that we can afford. And of course, Discord is open in the keynotes room. Does anybody have a question? You can type it in the chat. You can raise your hand. Okay, Jim, just mute yourself.
Great. Yeah, very nice keynote. I'm always very excited to hear about use of automated testing in PCG and industry. The question I have is, you know, with the tweaking tool, how did designers actually go about making use of the tweak suggestions that came back?
So, I mean, we are still in the prototype phase, right? So we are doing a few things. One is we have worked very closely with designers to incorporate all the, like, you know, concepts or, like, you know, things that they take into account. We have also provided them this thumbs up and thumbs down and give us comments so that we collect their comments. But the next iteration is actually, the idea is that we use the thumbs up and thumbs down to refine our tweaking and to learn the score function. So at the moment, we just have a very crude score function, but that's like the idea for future.
Okay, thank you.
Okay.
All right, Rodrigo, can I ask the last question? And then we have Discord as well.
Yeah, thanks for the talk. It was really interesting. I have a question about human likeness of the bots. And you mentioned that when you're doing supervised learning, you train directly on human data. But when you're doing reinforcement learning, you have these other intrinsic metrics so that the bot learns to play different types of combinations, etc. Does any of that have an impact on human likeness? How do you know that? How do you measure this for the reinforcement learning? How do you know that the bot is human-like or not?
I think that's a very good question. So, like, it's very easy to get to human-like play when it comes to supervised learning. But I mean, for reinforcement learning, so far we have, like, our focus hasn't been on to have a human-like gameplay. But having said that, we know, like, looking at the log of, like, player data, we know that, like, you know, creating the special candies, for instance, is like a quite common skill that the players use, and that's why we got inspired to incorporate that in our agents. But this is an area that we haven't started looking at for reinforcement learning.
Thank you.
All right. Thank you very much, Sahar. It was a great talk and really interesting to see what is going on outside our bubble.
Thank you. I just wanted to also apologize. Like, in the like when I started, I had a timer here that got paused for some reason, so I lost track of time a bit. So
it sounds like the FDG conference.
Went over.
It's okay. It's on brand. We're running a tight ship, but thank you very much.
Yeah.
And I hope
thank you for having me.
All right.
Bye.